Hello everyone, welcome to SREEACADEMY. In this session, we will see previous year questions from the basic electricals from 2021 question paper. Okay, so these are all previous year questions only. Okay, so we will give all the previous year questions daily basis. Okay, so this session we will discuss one subject, next session another subject, next session another subject, like that. Okay, so all the subject question papers, okay, like previous year questions we will be giving for you. Okay, so before the exam, don't forget to practice these questions. Okay, let's see the first question. The current waveform for a purely resistive circuit. Okay, so they are asking the current waveform for a purely resistive circuit. Okay, options: leads voltage by 90 degree, is in phase with the voltage, lags the voltage by 90 degree, alternately leads and lags the voltage. Only one thing. Okay, purely resistive load, whenever only resistance or pure resistance is there, voltage is in phase with current. Voltage will be in phase with the current, otherwise current is in phase with voltage, we can understand. Okay, that means the angle difference between voltage and current equal to 0 degree, or angle difference between current waveform and voltage waveform is equals to 0 degree. Okay, so this is a simple question and so many times they have asked. Okay, so for the analysis, okay, we will see some more elements also. Okay, so whenever only resistance is there, okay, only resistance is there, angle will be 0 degree. Whenever only inductor is there, angle will be plus 90 degree. Whenever only capacitor is there, angle will be minus 90 degree. Now for example, okay, whenever RL circuit is there, okay, for example RL circuit will be there, the angle, how it will be the angle, what is the angle difference between voltage and current, so that we need to understand. Okay, you see, RL circuit means if only resistance is there 0 degree, if only inductance is there 90 degree, if RL both will be there, it will be between 0 to plus 90. Okay, so this is the answer. So the whatever angle phi is between 0 to 90 degree it is. Okay, and whenever RC circuit will be there, okay, just observe, whenever only capacitance is there minus 90, whenever only resistance is there 0 degree, whenever both RC circuit is there, okay, then it is 0 to minus 90, otherwise minus 90 to 0 we will write down. Okay, so minus 90 phi less than 0 degree. This is for the RC circuit. Okay, that means whether current lags or current leads, that also we have to understand. Okay, sometimes they will ask, okay, so whether current lags or current leads, current is in phase or not. Okay, let's see. Whenever purely resistive load is there, current is in phase with voltage. 0 degree means no angle difference between voltage and current, 0 degree. Okay, that is in phase. Whenever inductor is there, current lags. Okay, so current lags voltage by 90 degree. Understanding, right? Current lags voltage by 90 degree. Otherwise, we can write down the same thing only. Current lags the voltage means voltage leads current. That's it. Okay, so lagging leading means advance. Okay, so all the vectors rotates in. Okay, so I will give you two things. Okay, so this is x and this is y. If someone asks you which is leading and which is lagging, means we have to rotate these things in anti-clockwise direction. Okay, if you rotate in this direction, x is going first, after that y is coming. Okay, for example, angle difference between these two is theta, means x leads y by an angle of theta, otherwise y lags, that means it is delaying. Okay, y is delaying by an angle of theta when compared to x, like that we have to give. Okay, so in capacitive circuit, current leads voltage. Okay, current leads voltage. Similarly, RL circuit also, current lags voltage by an angle of phi. This is not 90, not 0. Okay, phi it is. Okay, so now whenever RC circuit will be there, current leads voltage by an angle of phi. What is that phi value? Between minus 90 to 0 degree it is. Okay, so now for this question, answer is current waveform for a purely resistive load is in phase it will be. Okay, so in phase we can understand. Okay, in phase with the voltage, that is the answer for this question. Okay, whenever you are studying at that time, we have to understand all these other models also, what they can give also. Okay, the next question is, when two capacitors connected in series, their total capacitance, they are asking, whenever two capacitors are connected in series, their total capacitance. Okay, series connection, Whenever two resistors connected in series R1, R2, so how you will write down R1 plus R2, you will get equivalent, you will get as R1 plus R2. Whenever two inductors L1, L2 are connected in series like this, then also L1 plus L2 you will get, okay. So whenever two capacitances connected in series like this, C1 and C2, what is equivalent you will get? C1, C2, okay. So C equivalent, otherwise 1 by C equivalent equal to 1 by C1 plus 1 by C2. So same thing only, we can simplify like this, okay. C equivalent equal to C1 C2 divided by C1 plus C2. Okay, so that is the formula. No need to write all these things. Okay, directly if you know the formula, write down this one only. Okay, so what they have given, when two capacitances connected in series, their total capacitance. Okay, options: doubles, decreases, increases, remains same. Okay, they have not mentioned anything. Okay, so both the capacitances are equal or not equal. They have not told anything. Okay, whenever both are connected in series, what is equivalent? C1 C2 by C1 plus C2. If you just take some value, okay, so take C1 equal to 3 microfarads, C2 equal to 6 microfarads, what you will get? 3 into 6 divided by 3 plus 6, what you will get? So 3 into 6 is nothing but 18, 18 divided by 9 is nothing but 2 microfarads. Because only for practice only I am doing these things, okay, so directly we have to answer. Whenever two capacitances connected in series means directly we will get the value less than both. Okay. So whenever two capacitances connected in series, the equivalent value is less than this one and less than this one also. So what will happen means it will decrease. Okay. C equivalent will decrease. Decrease will be the answer. Understanding, right? So how it will be means we have to use this one. Okay, some example you take 1 and 1, you take 1 into 1 divided by 1 plus 1. So what you will get? 1 divided by 2, 0.5 you will get. Less than 1 it is. Okay, so 0.5 means less than 1. So always you will get less than the value only you will get. Okay, so answer for this question is decreases. Okay, okay, next question. The power factor of an AC circuit can be found using the formula power factor equal to, they have given the options, okay, volt amperes divided by watts, volt ampere into current, watts divided by volt amperes, volts into volt amperes. Okay, so by seeing all these things, okay, so you may just check, okay, check the units and directly give, okay. Otherwise for the information, okay, I am giving some more things, okay. For any of the AC circuit, okay, so in any AC circuit there will be three types of powers. One is apparent power, another one is active power, and another one is reactive power. Okay, so total three powers will be there. First one is apparent power, otherwise complex power it is. Okay, so it is called complex power. Okay, so complex power, otherwise we can call as apparent power. Okay, so and the complex power is equals to, this is active power, otherwise we can call as real power. Okay, so this is nothing but real power. Okay, plus J into, so this is imaginary it is. Okay, so imaginary term it is, we can call as reactive power. Okay, so active power and this is nothing but reactive power it is. Okay, so complex power is equals to active power plus reactive power. Okay, these are only for the information. Okay, if you know directly we can answer that question. Okay, so what are the units of complex power means? Units of complex power is volt amperes. Okay, units. Okay, active power units is nothing but so these are watts. Okay, active power units are watts. Okay, so watts, and reactive power units are volt amperes reactive. Okay, so volt amperes reactive. Okay, so unit of this one is nothing but watts, unit of this one is volt amperes reactive, unit of this one is this is nothing but volt amperes. Okay, so generally you will be knowing this one as VA, otherwise KVA, otherwise MVA, like this units will be there. Okay, so for the machines you will be seeing like this. Okay, so and for watts, okay, so otherwise kilowatts we will see, otherwise megawatts, otherwise gigawatts, like this. Okay, unit of this one kVAR. See, this is VAR. If you multiply with 1000 it will become kVAR. Okay, so otherwise MVAR, like this. Okay, so now what they are asking, the units. Okay, so power factor they are asking. What is power factor? Power factor is nothing but, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay, so how much is the active power in the complete power? Okay Okay, so what is the power factor? What is the active power in complete power? What is the active power in complex power? Okay, so what is the active power in complete power? That is nothing but power factor. Okay, so what is the unit of this one? Volt amperes. This is watts. Okay, so this is watts. Numerator, okay, so watts only it is. Okay, so watts divided by, so denominator, what is the units? Volt amperes. Okay, so volt amperes. Directly we can solve. Okay, so no need of all this. If you know this formula, directly we can give within 10 seconds only we can give this answer. Okay, so watts divided by volt amperes, watts divided by volt amperes, that is the answer. Okay, similarly they may ask what is the unit of reactive power? Unit of reactive power is volt amperes reactive, unit of active power watts, unit of apparent power volt amperes, otherwise kilovolt amperes, otherwise mega volt amperes, like this. Okay, these are all some of the previous year questions only, they have asked in different years. Okay, the next question is the condition for the validity of Ohm's law is. Okay, so condition for the Ohm's law. Okay, so what is the condition it should satisfy for the Ohm's law? Okay, so what is the Ohm's law we have? Ohm's law is simple, that is voltage equal to current into resistance. Okay, so V equal to I into R. Okay, so directly we can understand something. If resistance is constant, okay, if the resistance is constant, voltage is proportional to current, otherwise current is proportional to voltage. Okay, so whether V is proportional to I or I proportional to V is same thing only. Okay, so for that resistance must be constant. It must be constant. That means resistance should not vary. Okay, resistance should not vary. To satisfy the Ohm's law, resistance value should not be varying. Okay, so that is the answer. Okay, let's see the options now. Temperature should be constant. Current should be proportional to voltage. Resistance must be wire wound resistance. Fourth one, resistance must be varying. Resistance must be varying, they told. This is wrong. Okay, so resistance should not vary. What they told? Resistance must be wire wound type. They were telling wire wounding only resistance. So why it has to be like that? I will take one transmission line, aluminum conductor I will take. There is no restriction. We can take wire wound one. Otherwise any transmission line, something we can take. Okay, so this is also wrong. Okay, so current should be proportional to voltage. Current is proportional to voltage. That is only Ohm's law. But because of what it is satisfying whenever resistance is constant. How resistance is constant? For any of the conductors, okay, so resistance will be depends upon temperature. Okay, if temperature increases, resistance will increases. Then that type of material is called, it is having a positive temperature coefficient. Okay, positive temperature coefficient. If temperature is increasing, resistance decreases means that is negative temperature coefficient material. Okay, so now whatever it is, to satisfy the Ohm's law, resistance should not change. It should not increase and it should not decrease also. That means resistance should not change. How resistance should not change? Temperature should not change, like this. Understanding right? Temperature should not change. That is the only one. Okay, so that means temperature should be constant. When temperature is constant, definitely resistance will be constant. Then only V is proportional to I. Then only Ohm's law will be satisfied. Okay, so very simple question, and so many times they have asked what is the Ohm's law means. This is the Ohm's law. V is proportional to I. How we can write down like this directly? Because resistance we are considering constant. When resistance is constant, whenever temperature is constant, temperature should be constant. Okay, so whenever temperature is constant, then only, okay, Ohm's law will be validated. Okay, so that is the answer for this question. Okay, and the next question is property of material which opposes the production of magnetic flux is called. Okay, so which opposes the flow of magnetic flux, it has to be actually. So the question, property of material which opposes the flow of magnetic flux is called. Okay, so otherwise if something is more, flux will be less. If something is less, flux will be more. What is that something they are asking? Okay, so let's compare these things. Okay, so we know the Ohm's law. What is Ohm's law? V equal to I into R. Okay, so otherwise we can write down something, current is equals to voltage divided by resistance. Okay, so let's see, if resistance is more value, current is less. If resistance is very less value, then current will be more. Okay, so similar to this is in the electric circuits. Yes or no, this is in the electric circuits. Okay, similarly in the magnetic circuits also we can give. Okay, so whenever one magnetic material will be there, so in the magnetic material, north pole and south pole will be forming whenever current flows on the winding, so there will be flux production. Okay, so how much flux has to flow, who will decide? So generally we can give, okay, so the flux is equals to, we can give as mmf divided by reluctance. Okay, so reluctance, you know already, the current is equals to voltage divided by resistance in the magnetic circuits. Okay, so this is in the magnetic circuits. Okay, so in the magnetic circuits, the flux we can give as mmf per reluctance. Okay, if more reluctance, less flux; if less reluctance, more flux. Okay, so that is what we can understand. Okay, now we have to compare something here. V is nothing but electromotive force, otherwise voltage we will call. Okay, in the electric fields, okay, in the electric fields, this is magnetic fields. Let's compare. Okay, if it is voltage here, what is here? This is mmf. Okay, voltage can also be called, okay, how we can call the voltage? EMF. Yes or no, electromotive force. Okay, similarly here mmf we can call. Okay, similarly here resistance. Okay, so resistance, how we can call, how we can denote this resistance? We can denote as R. Okay, and here in the magnetic circuits, what is the equivalent of resistance there? That is reluctance. Okay, so this is reluctance. Generally how we have to represent the reluctance? Like this. Okay, and what is another one? Current. Okay, so current I, we can in the magnetic circuits, what is the equivalent for that? That is flux. Okay, so flux phi. Okay, so these are also important only. Okay, so they used to ask some match the following also, sometimes we have to answer based on this. Okay, so anyway, answer for this question. Okay, so property of material which opposes the production of magnetic flux. Okay, which opposes reluctance will opposes. Answer for this question is reluctance. Okay, so standard bits these are all. Okay, it will never change even after some years also, these questions will be same only. These questions will never change. Okay, the next question is, resistance of the conductor is doubled by keeping the potential difference is constant. Okay, so the rate of generation of heat is, okay, so they were just asking resistance. What they did, they have doubled this resistance. So whatever resistance is there, it will become 2R. Voltage before also same and now also same. What will happen to the heat generation? Okay, how much is the heat produced in that resistance? That's what they are asking. Okay, so now we have to consider one thing. In any of the resistance, okay, in any of the resistance, we have to consider something. Okay, so if some voltage we are applying across this resistance, definitely some current will flow wherever plus. Okay, so this is wherever current enters, that is plus, wherever current leaves, that is minus. Okay, so this is normal case. Now what they did, resistance they have doubled. Now 2R resistance is there, 2R resistance is there, by keeping the voltage as same. Okay, so by keeping the voltage as same, now you observe what is the current will flow in this one. Resistance is increased means current will decrease. Resistance is doubled means then automatically current will be half. Okay, so otherwise you can observe here current I equal to V by R. Okay, so now here what is the current you will get? V by 2R. That means how the current will be? It will become half of the value. Okay, so it will become, so I by 2. Whatever previously in this one I current, here it will be I divided by 2 it will be. Okay, so now what they have asked, heat of the heat generation in this. Okay, so for example, heat means resistance will definitely consumes the energy, right? Okay, it will dissipate the energy in terms of heat. Okay, so whatever heat produced here, we can consider, first we will take the power, that's enough, right? Okay, P equal to I square into R. Okay, so I square into R it is. Same here also, if you just check P equal to I, what is the current here? Here current is I by 2. Okay, so I by 2 whole square into R. What is the value of R? It is 2R. Okay, so substitute, you will get I square into R, actually into 2 divided by 4, okay, so 2 square is 4 and into 2 will be there, so you will get divided by 2. I square into R divided by 2 we got, okay. Whenever resistance we are doubling like this, so what happens to the power? Power is getting half because current is decreasing, right? Okay, so that means whatever power dissipation in the resistor, in the 2R resistor, it will be half, means definitely energy, heat energy produced in the resistor is also half. Okay, so what is the answer for this? The rate of generation of heat is, okay, so that will be half. Option 1 is correct for this. Okay, the next question is, which of the following statement is not correct? Okay, so they have given 4 statements in the option, so they were just asking which is the wrong statement. Okay, so remember, whatever statement they are giving, whether they are asking the correct one or wrong one, we have to decide first. Okay, then only we can answer properly. Okay, so first option, magnetic field lines form a continuous closed curve. Is this a correct one or wrong one? Okay, so if you take one magnet, any bar magnet or anything, okay, so north pole to south pole, always flux lines will flow. Okay, so some flux lines will flow. So these are continuous closed loops only, right? Okay, so these are continuous closed. However, this side will be there, other side also there will be flux lines. Okay, see the option, magnetic field lines form a continuous closure curves. Okay, so these are continuous closure curves only. Okay, so this option is correct. Okay, whatever this statement is correct. Okay, so next one, magnetic field line do not intersect each other. Why they will not intersect? So they will definitely intersect. Okay, so whatever magnetic field lines are there, so they told they do not intersect. They do not intersect with the same magnetic flux lines. These flux lines will intersect with another one, but these flux lines will not intersect with the same magnet flux lines. Understanding, right? If here one flux line will be there, means another flux line will be there, so those two will never intersect. That's what they have given, magnetic field line do not intersect each other. So this is also correct statement only. Okay, and third one, direction of tangent at any point on the magnetic field line curve gives the direction of magnetic field at the point. Okay, so in our childhood, okay, before 10th standard, we might have did the experiment. One compass we will keep here, wherever it will show. Okay, so next point we will keep, from that point again we will keep the compass, wherever this arrow will show we will keep. What we are doing actually is the tangent only we are giving. Okay, so the tangent, the whatever arrow is there, that is nothing but the tangent. Okay, so otherwise directly for this point whatever be the tangent, so that is nothing but so the next point. Okay, so next point, again next point, if you add all these points, then you will get the magnetic field lines. Okay, otherwise the flux lines same only. Okay, so third option is also correct only. Now what they have given, outside the magnetic field lines go from south to north pole. They have given magnetic flux lines will go from south to north pole. Okay, outside the magnetic field, always flux lines are from north pole to south pole. Okay, so north pole to south pole outside the magnet. Okay, inside the magnet, to complete the closure path, how it will be, north pole to south pole, the flux lines will be going like this, inside it will be like this. Understood? So inside, outside it is different. Okay, just understand, always remember the outside only. Always flux lines flows from a north pole to south pole. Okay, we have to remember this. Okay, so what they have given, outside the magnetic field lines go from south to north they mentioned. So this is wrong option. So this is our answer. Okay, so what they have given, which of the statement is not correct? Okay, so this is the not correct statement. Okay. Okay, these are questions from the basic electricals. Okay, so anyway, in the different session we will see the other subject questions also. Okay, so the next videos will be coming from the power systems, measurements, power electronics, like all these subjects. Okay, so one by one we will be completing. Okay, and thank you so much.